Hey folks, couple viewer questions here. Josh and Jeremy both got electronics and sensor kits for Christmas gifts. I cool parents. They're actually, you know, helping the kids learn what they're interested in. The quick question was on breadboards. There's a couple questions here, but yeah, what exactly is a breadboard? It's, as I've talked about before, it's for prototyping. They come in all different sizes. Even this is considered a breadboard, although it has the soldered pads. To give an example based on the Arduino, what you would do is assemble it. Initially, you would breadboard your intended circuit. When you get it, everything works the way you want it to with the Arduino. You would take everything off of the breadboard and solder it down to the printed circuit board. And it allows you to create your wiring diagram just like you had it here, but permanently on the shield that goes on the Arduino. All right. So, quick and dirty explanation of a breadboard. Again, top and bottom are power rails. It is the entire columns from side to side in the width of the board. The entire top and bottom row. The actual circuit fields are in rows. You can see them numbered here from row 1 to row 63. As an example. None of these pins running in the column form are interconnected. Only the rows are connected. I can kind of turn this over. If I can flip this a little bit. Sorry, I'm trying to get a hold of this foam and it's not cooperating. All right, there we go. So again, you can see here's our power rails. Right here, you can see that they are a complete connection. Here's our circuit row. Each one of these is an individual circuit row. I'm trying to get some light off of that for a split second. So you can see that only our rows are connected, not in the column order. The only column connection is in the power. If I can close this back up a little bit. I actually hate opening my breadboards like that. But to show you guys, Josh noticed a difference with his. His is like mine is. You can see the color stops as you're moving across the power bus. Right? What it is this board has two power zones completely across the top and bottom. This one actually has 4 different power zones. Does it mean you need different voltage? No. But if you're working with multiple voltages on a single board, that's the type of board you're looking for. All right. Josh asked for something simple to build to impress his father. So let's talk about, we're going to light up an LED, and then Josh had a follow-up question. A real-world application. LEDs typically have 2 different length legs. The longer leg is the cathode or the positive leg. The shorter leg is the anode or the negative leg. I'm going to give you this as the lesson you need to learn. Don't trust the leg length. Somewhere here I have a bag where the LEDs are all the exact same leg length. Both the cathode and the anode are the same length. So what you need to get in the habit of doing and be able to do is look at the LED inside. You can kind of see that there's a flag in the LED itself. The flag is the anode. So the flag on the pole is the anode. The straight pole, or straight wire as this case may be, is the cathode. You know, I'm oversimplifying it, but always look for the flag. The flag is negative. The other one is positive. So as I double check this one, which I know is right because I've used it I don't know how many times, let's go in your little kit and get out your power supply. Mount it on the board. Let's check our voltage for the top rail. Should be set to 5 volts. On this one, the inner position on the jumper is 5 volt. The outer position is 3.3. So let's get that in 5 volt. One more time, I'm going to check my LED. Let's take our negative lead or the anode on pin 25, the positive on pin 20. Just ease that down into the board. You're going to need a resistor. 320 ohms should suffice. Actually, I think voltage-wise, 320 is the correct one. I'd have to sit down and do the math, but find a 320 ohm resistor. Your kit, they should be in a bag most likely. Sometimes they're loose depending on who makes the kit. But yeah, find your 330 ohm, resistor and get one off of the pack. In this case, the resistor acts as a ballast. If you think about a fluorescent light, the ballast controls the current to the bulb. We have the exact same thing here, except done with a resistor. Well, they're both resistors, but all right. One leg of the resistor is going to go into pin 20, which is our positive. We're going to bring the other one over to pin 15. I'm giving you 5 so you got room to work. Okay. Now, you need 2 of your jumpers, whatever length you want to use. I'm going to try and keep these short just for the visual. We're going to come, let's go all the way down here in row 25 to make sure that we are in the correct row as the leg of our LED. We're going to catch 25 up on the common rail. Negative up on the common rail. Pin 15, positive, needs to go to positive on the common rail. Now we're going to bring in our power. Plug in our power supply. We're going to turn it on. There you go. There's your simple, easy circuit. Now, let's unplug this. Jeremy, I'm going to answer your next question, but in our case, it's going to involve using the Arduino. I don't know if you're there yet or not. You could do this with the Raspberry Pi by the same general principle, by an LED circuit lighting up, pulling a certain pin high. But your specific question was about industrial controls, and you specified a safety. So I'm highly impressed by that question, because you're obviously thinking down the road and thinking logical applications. I'm going to put in a momentary switch to act as our safety. So let's make the example that this HDMI adapter is a part that's going to get cut in an industrial piece of equipment. Our controller, it's going to run all the time. So in this case, I'm just using the blink sketch, but let's just say that the light illuminating is the trigger to power that cutter in the industrial control. Right now, you have an environment where the operator can stick their hand in at any time, and it would fire if it's wired up directly. We're going to extend this out to a safety control. It's just, it's oversimplification, but I think you'll get the idea. So the first things we need to do is, from our Arduino, I'm just trying to keep these runs short, we're going to bring our ground over to our rail. Okay, we've brought the power to the rail. Now we're going to bring our negative down to our actuator, which in this case we're just going to use the LED to emulate the trigger on the cutter. Now, what we need to do is be able to complete this circuit in a safe manner. so that the operator must push the trigger before our actuator can fire. Again, the LED imitates the actuator. So we know that if we come here right now, it would help if I brought my signal all the way down for that example. But we know that without our safety switch, that every time the controller fires, that cutter is going to fire. Okay, we know that cannot happen. So just to cut it out, we're going to run over and we're going to install our safety switch. In order for the safety switch to get to the trigger, we need to come out and catch across. Now you'll see that the circuit fires. Under a normal wiring circumstance, our cutter would go and cut this. But it's not getting supplied the signal to fire, to actually make the cut. So the operator comes in, puts his part down, lines it up, does whatever he needs to do with the pieces, pushes the button, bam. We've now completed that circuit. But if we take our finger off, you can see what's happening here. In a normal industrial environment, this part would be beyond the operator's length. So the operator would lean in, put the part in, do what they have to do, lean out of a safety area and push the button. Then it would fire, make the cut, and stop. Now, the circuit can fire, again, the trigger can fire, but it will not activate the equipment until you've pushed the safety button. So, yeah, I'm really, really impressed with that one, Josh. That's thinking ahead and thinking down the road. I doubt they would have taught you that in school, but I'm so tickled to hear you actually make that question, come up with that question. So I hope that answers your questions, guys. See you soon.